Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of scatterplots. This is standard 8.11a in the great state of Texas, and we are using item number 40 of the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the daily attendance here of a bowling alley recorded for 15 days. And all that simply means is that if you count the number of dots, you would get 15 dots. So we're not necessarily looking for 15 on either axis here. What we are looking for are the number of lanes rented each day. So that's going to be our x-axis. And the number of people who bowled that day, that is our y-axis. And so we need to find a statement. We're really looking to see, are we seeing any trends in this scatter plot? So it's a scatter plot, not necessarily a traditional graph into where you're going to find a linear equation. So we can't break this down into a linear equation. It's not a function, right? Because we've got multiple dots on the same x coordinate, right? So it kind of fails that vertical line test, but it is a scatter plot, which means it's messy, real-world data, and we can find a trend. So that's what we're really looking for. We're looking for a trend line. So is there something visually that lets us know that there is a pattern here? And you're probably noticing that we've got a pattern down here, starting with 4, and it kind of moves up to the right, up to 10. So what I'm going to do is I'm going to draw a line, and what I'm going to try to do is I'm going to try to hit in between some of these dots here. If I can hit in between, that's fine. Sometimes I can't, but I'm looking to see if I can find a straight-ish line that kind of encapsulates most of my data. You don't really want to make it wavy or curvy, and so you want to try to get that line in between as many dots as possible, or really on some of the dots, so it kind of captures most of the data. And that looks like that's a pretty decent trend line. So since we have a trend line, that means we can make a statement about a relationship between the number of lanes rented and the number of people bowling. So F, there is a non-linear association. Okay, well, non-linear means no line. And that's a problem because I just drew a line. So a non-linear association between the number of lanes rented and the number of people who bowl. No. There does seem to be a linear relationship because, look, you only have a small number of people bowling on the number of 4 lanes, right? So you've got your, call it about maybe 18 and 22. But if you get up to 10 lanes rented, look how many people you got. 60, you got 70, maybe like 68. And it makes sense. The more lanes you rent, the more people you can fit on a lane. Lanes, looks like they're taking maybe about 6 to 7 people per, anywhere from 5 to 7 people per. All right. So it's not going to be F because there is a line. There is a negative linear association. All right, so linear means line, yes, but linear doesn't necessarily encapsulate everything we need, because look at this. It says negative linear. So remember, this has a slope, and since it's moving up as we go from left to right, it's a positive slope. Negative linear would kind of be like this. It would be the more lanes rented, the less people. This is a negative slope. The more lanes rented, the less people that show up. No, that doesn't make sense. The more lanes rented, the more people show up. As your x increases, your y also increases. There is no apparent association. No, that's when you get dots all over the place. So this would be no apparent association, is if you just get dots kind of like all over the place. It looks like someone just spilled dots on the graph. That's no association. There is a positive linear association, all right, and that is what we're looking for. As your number of lanes rented increases, so does the number of people bowling. It is positive, it's moving up to the right, and it is linear, so our answer is J.